The formula that we use to define variance is not that easy to use by hand. It requires a sort of two-stage computation. Starting from the raw data, x1 to xn, you have to first compute the mean, and then you have to compute all the xi minus x bar whole squares, and then finally compute their mean. There is another equivalent formula that is somewhat easier in the sense that it requires only one stage computation. Not that you will typically do the computation by hand, but still it is good to know. The formula is this, which is summation xi square by n. From that you subtract summation xi by n whole squared. So here you compute the sum of all the values as well as the sum of all their squares and then plug them into the formula. Now let's see if we get the same answer. Okay, we are back with the same data set as before, the same number of values. There are 6 values and we want to compute the variance. But this time we do not want to work from the raw definition, but instead we want to use this alternative formula. Now in this formula, of course, we recognize this quantity inside the parenthesis as our familiar x bar. So let's start the computation. The first step is already done. You have to add them up. We already know that the number is 25, and we know from that our x bar is going to be 25 upon 6. This much is just as in the last case. Now in the last case, we had to subtract this number from each one of them, create another column. But here I do not have to compute xi minus x bar anywhere. Instead, I need to compute this sum, summation xi squared. So I shall just square each of these numbers and create another column here. So the first thing here would be 9, 3 squared, then I'll have 25, here 4, so it will be 16, 25, 1 and 49. The total of all these numbers turn out to be 125. So I have got this as 125. So now I have to apply this formula, and it will be 156 by 6, that is summation xi squared by n, minus square of this. So this is summation xi, I am dividing it by n, which is 6, and squaring the entire thing. This quantity turns out to be 3.47, and that is precisely the answer that we had got using our original formula also. Now of course that is exactly as expected, and if I now want to compute the standard deviation, that is again as before, I just compute its square root, which is 1.86. Of course rounded off to 2 decimal places. Now you can clearly see why this formula is more advantageous than the last one. First of all, just look at the computational table. I do not have 3 columns. I have only 2 columns. Then I could compute this column directly by looking at xi's. In the earlier example, or in the case of the original formula, I had to compute x bar, then subtract x bar from these. Only then I could come to the second column. So the second column was not an immediate consequence of the first column. It's not that this number came directly from this, because you had to compute the mean by combining everything, subtract the mean from each one of them. So even computing this second column was difficult. But in this case, the second column is just directly, this is 3, so this is 9. This is 5, then this is 25. If you change these numbers, then these numbers are not going to change. And you do not have to do any further column. So that is why this formula is much easier to work with when you are doing hand computation. Now, because the two formulae proceed in 2 different ways, as a result, when you are using approximate numbers like we are doing here, we are rounding things off, It may happen that in some example, if you use the two different formulae, one is this and the other is the original formulae, the answers might differ a little bit, possibly in some decimal digit somewhere. That is because of different ways of rounding off. But theoretically, they are always going to give you the exact same value. In our case also, even after rounding off for two decimal places, I am getting the same value. It is possible to prove that these two formulae will always produce the same answer. Let's not bother about the proof here. The reading material has the proof anyway, and it is nothing terribly important for learning statistics. In fact, the alternative formula itself is not terribly important unless you are forced to do hand computation. In the next video, we shall learn what is important: computing variance using LibreOffice.